In this video, we will utilize the 2D high-speed dynamic area mill toolpath to remove the material in the middle of the part with the part now flipped over. To do this, select Toolpaths, 2D high-speed, dynamic area. When the chaining dialog box appears, leave the default settings as shown. Now select the first chain on the inner circle. Once complete, select the OK button to exit the chaining dialog box. The Chain Options dialog box will appear. From here, select Single Region as shown. You can now press the OK button to exit the Chain Options dialog box. In the Toolpath page, select the Dynamic Area Mill and then from the Tree View list, choose Tool. Now, click the Select Library Tool button and then choose Filter. Select the None button and then under Tool Types, choose the Flat End Mill icon. Also, under Tool Diameter, pick Greater Than and input a value of 1. Once complete, select the OK button to exit the Tool List filter. In the Tool Selection dialog box, you should now only see flat end mills larger than 1 inch. That being said, choose the 1.5 inch flat end mill and then select the OK button. Your tool will appear as shown. Input the following comment. Now select the cut parameters. Make sure that all of your parameters appear as shown. Change the percentage of tool diameter to 500. Once the parameter has been adjusted, select Depth Cuts. Ensure that Depth Cuts is disabled. Now select the entry motion. Set the entry method to helix only. Also, set the helix radius to 1 and the rest of the parameters as shown. Ensure that Output 3D Arc Moves is enabled. Enable entry feeds and speeds and input the following values. Once complete, select the linking parameters. Input a depth value of -1.25 absolute. Also, ensure that the top of stock is set to absolute. The rest of your parameters should appear as shown. Once complete, select the OK button to generate the toolpath. We will now backplot and verify the operation to ensure that the tool motion is correct. Select the backplot icon. Ensure that Tool and Workpiece are enabled and select the Play Simulation button. Now select the isometric view and Fit icon. Your toolpath will appear as shown. You can now exit backplot. From here, select all of the operations and verify your part. Your part will appear as shown. Using your mouse, you can rotate the part to view what has been changed. You can now exit Verify. Finally, we will rename the NC file and then post the file. The 2D high-speed dynamic mill operation in setup number 2 kept the NC name from setup number 1. We need to rename this operation so that it will create two separate programs. The 2D high-speed dynamic mill operation in setup number 2 kept the NC name from setup number 1. We need to rename this operation so it will create two separate programs. Select only operation number 9 as shown. Right-click on operation number 9, scroll down to Edit Selected Operations, and then choose Change NC File Name. When the new NC Name dialog box appears, select Setup number 2. Once complete, choose the OK button to apply the changed NC name to operation number 9. You should now be able to see setup number 2.nc in the last item of text for operation number 9. We will now post the file. Ensure that all operations are selected. Now choose the Post Selected Operations button from the Operations Manager. The post-processing dialog box will appear. Select the OK button and save your file. Additionally, save setup number 2. The Mastercam Code Expert will appear. Ensure that your tool operations appear correct for your machine. You can now exit the Mastercam Code Expert. Finally, save your updated Mastercam file. This will complete tutorial number 5.